welcome to another video tutorial on time and work. In this lesson, we are going to be doing a refresher question followed by middle level difficulty questions. So let us begin with our first slide. The first question says that tap A can fill a tank in 10 hours, whereas tap B can fill that tank in 15 hours. If both the taps are open simultaneously, and how much time the tank gets full. Now you see, this is a very basic question of time and work. And since we have got the time taken by tap A and tap B filling the tank individually, we are simply going to multiply these two time durations and divide them by their sum, right? So our formula would be the time taken by taps A and B is equal to time A into time B divided by time A plus time B, right? Which is equal to 150 over 25, which is equal to 6 hours. Now you see, this is the time taken by tap A and tap B to fill up the tank if both the taps are opened simultaneously, right? Machines A and B take 6 and 8 hours respectively to complete the work. Both start working together, but A stops functioning after 2 hours. How much time would B take to complete the work? Now let us first organize our solution. You see, we have been given the time taken by machines A and B to complete the work. Therefore, in order to make our calculations easy, our first step would be to take the LCM of 6 and 8, which is equal to 24. That is, 24 units of work is to be done. Now we know that time into rate is equal to the work done. Therefore, the rate of machine A will be 4 units per hour and that of B will be 3 units of work per hour. Now, when two machines are working together, we add the rates of the two machines. Therefore, 4 plus 3 is equal to 7 units of work per hour, right? Now, the question says that both machines start working together for 2 hours, which means that A and B work together for 2 hours, that is 2 into 7 is equal to 14 units of work completed in 2 hours, right? Okay, now we have a total of 24 units of work to be completed. 14 units of work is already done. The remaining units of work would be 24 minus 14, which is equal to 10 units. Now, to find the time taken by B to complete 10 units of work, we are going to divide 10 units by the rate of work of C, which is 3 units per hour. So, our answer would be 10 over 3 hours. If you want to convert it into minutes, we will multiply 10 over 3 by 60 and our answer would be 3 hours and 20 minutes, right? Let's move on to our next slide. A and B, when working together, take 4 hours to complete the work. B and C take 3 hours to complete the work. And A and C take 6 hours to complete the same work. We have to find the time taken to complete the work when all three work together and the time taken to complete the work if only C was working. Now, we will assume W, or the work done, to be the least common multiple, that is the LCM of 4, 3 and 6 hours, which is equal to 12. We assume the work done to be 12 units in each case, right? Now, this means that A and B complete 3 units of work per hour, B and C complete 4 units, and A and C together complete 2 units of work per hour. We have to find the time taken to complete the work when all three work together. We have the combined rate of A and B, B and C, and A and C. So to find the first answer, what we need is RA plus RB plus RC. So we are going to add all the three equations. So adding the left hand side, we get 2 times RA plus RB plus RC, and adding right hand side gives us 9. Dividing 2 on both sides, we get RA plus RB plus RC equal to 4.5 units of work per hour. So the time taken by A, B and C together will be 2 hours and 14 minutes. Now for the second question, the time taken to complete the same work when only C is working, we need to find RC, and we know that TC into RC is equal to 12. We have RA plus RB plus RC equal to 4.5, and we also have RA plus RB equal to 3. We can substitute this value in the equation RA plus RB plus RC is equal to 4.5 to get 3 plus RC equal to 4.5. Transposing 3 to the right side, we get RC equal to 1.5 units per hour. So the time taken by C to complete the work would be equal to 8 hours. P can do a work in 12 hours and Q can do the same work in 18 hours. P started the work and Q joined him after 6 hours. How much time did it take in all to complete the work? Now you see, we will assume the work to be the LCM of 12 and 18 hours, which is equal to 36 units. So W would be 36 units. We know that time into rate is equal to W. Therefore, the rate of P would be 3 units of work done per hour, and that of Q would be 2 units of work done per hour, and their combined rate would be the rate of P plus the rate of Q, which is equal to 5 units per hour. Now the question says that P started the work and Q joined him after 6 hours. So before Q joins P, what we're going to do is we're going to see how much work is done by P, and for that we're going to multiply the rate of P by the number of hours, which is equal to 3 times 6, which is equal to 18 units. Now the remaining units of work would be 36 minus 18, which is equal to 18 units, and the time taken by both P and Q to complete the remaining work would be 18 over 5, which is equal to 3.6 hours. Therefore, the total time taken to complete the work would be 6 plus 3.6, which is equal to 9 hours, right? Now, to convert 0.6 in minutes, we get 36, right? So the total time taken to complete the work would be 9 hours and 36 minutes. So our answer choice would be 3. Right? This question says that S can do a work in 24 days and N can do the same work in 40 days. S started the work and N replaced him after 12 days. In how many days from the beginning 75% of the work will be completed? Now you see, we will assume the work to be the LCM of 24 and 40 days, which is equal to 120. So we will assume W to be 120 units, right? Now we know that time into rate is equal to W. Therefore, the rate of work of S is equal to 5 units per day and that of N is equal to 3 units per day. Now the question says in how many days from the beginning 75% of the work will be completed. So 75% of work would be equal to 75 over 100 into 120, which means that 75% of 120 is equal to 90 units of work. Now the units of work done by S in 12 days would be 12, that is the number of days, into the rate of work, which is 5, right? So it is equal to 60. Now the remaining units of work would be 120, that is the total units of work minus the units of work done by S, right? So we're going to get 60 units of work remaining. Now you see, we have to find how many days from the beginning 75% of the work will be completed. So N will have to do how many units of work? It will do 90 minus 60, which is equal to 30 units of work to do after replacing S, right? Now the time taken by n to complete 30 units of work would be 30 over 3, that is 3 is the rate of work of n. Therefore, the time taken by n would be 10 days, right? So the total number of days to complete 75% of the work would be 12 plus 10, which is equal to 22 days. So our answer choice would be 4. An inlet tab A can fill a tank in 12 hours, whereas an outlet tab B can empty the full tank in 30 hours. If both the taps are open simultaneously, in how much time the tank gets full? Now, we will assume the capacity of the tank by taking the LCM of 12 and 30 hours, which is equal to 60. Therefore, W would be assumed to be 60 gallons, or the total capacity of tank would be assumed to be 60 gallons. Now, we know that time into rate is equal to W, therefore A can fill the tank at a rate of 5 gallons per hour and B can empty the tank at a rate of 2 gallons per hour. Now the rate at which the tank is filled, if both A and B are opened, what we're going to do is we're going to minus 5 by 2, because you see B is an outlet tap, right? So its function is to empty the tank. So we're going to subtract 5 by 2 to get the rate at which the tank is filled if both A and B are opened, right? So the time taken to fill up the tank if both taps are opened would be 60 divided by the rate at which the tank is filled if both A and B are opened, which is 3, right? So 60 divided by 3 is equal to 20 hours. So it takes 20 hours if both the taps are open simultaneously to fill up the tank in its full capacity, right? So our answer choice would be 20. This concludes our second video tutorial on time and work. I hope you've understood the questions well. In the coming few days, I'm going to upload a few more videos on time and work so that you understand this topic very well. So stay tuned to this channel, stay positive, keep your spirits high, and goodbye for now. Thank you.